Let's take a quick look at how you do the hypothesis tests to test a proportion in StatCrunch. In this problem, it says, in a study of the accuracy of fast food drive-through orders, one restaurant had 39 orders that were not accurate among 332 orders. Use a 0.01 significance level to test the claim that the rate of inaccurate orders is equal to 10%. Okay, so our claim is that the proportion is equal to 10%. Because this is an equals, this is going to be the null hypothesis. Now, it doesn't say anything about suggesting that it's more than 10% or less than 10%. That means that the alternative hypothesis is going to be that P is not equal to 10%. So what we have here is a two-tailed test. The null hypothesis will always be equals. So it's obviously not A. That leaves the other three. There's nothing here suggesting greater than 10% or less than 10%, so it's going to have to be C, which is what we'd already figured out. Now the test statistic is Z, but it comes from P cap, which is the proportion from the test, from the experiment, from the observations. A lot of times they will not give you the number, but instead they actually give you the percent. That's fine. If they say that X percent of 332 orders were inaccurate, which is actually giving us P cap. The way StatCrunch works, we have to actually put in the number. So just work a little bit backwards and take the percentage of N. So the test statistic deals with the numbers that came from the observed amount. We also know here that alpha is going to be 0.01 for this problem. Now, we don't actually put alpha in when we're doing the hypothesis test. If you're doing a confidence interval, you will put alpha in as part of your information. So to do this in StatCrunch, we'll go to Stat, Proportion Stats, one sample with summary, the number of successes. Again, if that's not given in the problem, you're going to have to take your percentage of N and work backwards to get that, simply because this is the way that StatCrunch is set up to take it. So you put in the number of successes here is 39 out of 332. The hypothesis is that P is equal to 0.10. It automatically fills in the alternative. Our alternative is the not equal to. Compute. It gives us the sample proportion, which is P cap. We don't need the standard error. Z-stat is going to be the test statistic. So this is what we put in here. 2 decimal places, 1.06. The p-value, 3 decimal places will be 0.289. The easiest way to do the conclusion is always to just use the p-test. That's what most technology is set to work with. For the p-test, you compare the p-value to alpha. if the p-value is less than alpha, we reject the null. They say it as if the p is low, the null must go. However, if the p-value is greater than alpha, we do not reject the null. This does not mean that we have proved the null hypothesis is correct. It simply means that we don't have evidence showing that it's not correct. Always remember that. You can never prove the null hypothesis is correct. You can only state whether or not you have enough evidence to reject it or not. If you reject it, you're basically saying that the alternative could be correct, especially in the case of a two-tailed test, because in the two-tailed test, your assumption might actually be that it's going to be higher than something, and the statistics show that it's probably lower. So in this case, because our p-value is 0.289, and we're comparing that to 0.01, and 0.289 is obviously way larger than 0.01. So our results in this case would be that we do not reject the null. So we've got two options down here on fail to reject the null. We know that's it. It's one of these two. There is not significant evidence to warrant rejection of the claim that the rate of inaccurate orders is equal to 10%, or there is sufficient evidence. Since this is a restatement in words of the null hypothesis, and we are not rejecting the null hypothesis, which says that it is equal to 10%, if we are not rejecting that, then we're saying there's not enough evidence to warrant rejection of the claim. So the answer here is going to be A. Does the accuracy rate appear to be acceptable? A 10% rate of having your orders wrong seems to me that it would be pretty unacceptable. So let's go with that. Let's go with that. So this is all we really need to do for most of the problems in this section. If you have any questions, let me know, and I will be glad to fix you up with an answer. Thanks.